let's talk about a material that has totally changed the game in modern engineering. I'm talking about carbon fiber. It's that secret ingredient in the fastest cars, the highest flying jets, and some of the most advanced tech on the planet. So, how did this simple black thread become a certified super material? Okay, let's start with a little riddle. What do you think a screaming supercar, the wing of a massive jetliner, and a satellite orbiting way up in space all have in common? I mean, they seem like they're from completely different worlds, right? But they all share one fundamental secret. And yup, that secret is carbon fiber. Look, this isn't just a small step up from old school metals, it is a giant leap. We're talking about a material that just completely shatters the old rules, where you had to choose between strength and weight.
This whole advantage really boils down to one key thing: the strength to weight ratio. In the world of engineering, that's like the holy grail. It means for the exact same amount of strength, a carbon fiber part can be way, way lighter than one made of steel or aluminum. That's not just a nice little improvement. That's what makes it a true super material.
But come on, how does a simple bundle of black threads pull off this kind of performance? Well, to get that, we need to zoom in. I mean, way in, all the way down to the atomic level. So here's the secret sauce. Its strength isn't just because it's made of carbon. It's all about the structure. The atoms are basically forced to line up in these almost perfect chain-like crystals. It's this super ordered arrangement that gives a single tiny filament, thinner than one of your hairs, its absolutely mind-blowing power. For such a futuristic material, it actually has a pretty long history. It all started way back with Thomas Edison, who was using these weak, carbonized filaments in his light bulbs. But the real game changer came in the middle of the 20th century. That's when scientists finally cracked the code on how to create those tightly aligned structures we use today, turning it from a cool novelty into a high-performance powerhouse. These days, the journey to create this super material almost always kicks off with a very specific ingredient, a polymer called polyacrylonitrile. We just call it PAN for short. You can think of it like the special starter dough from which something truly extraordinary is about to be baked. But turning that raw polymer into actual carbon fiber, oh, that is anything but simple. It's a seriously intense, transformative journey. It's basically a trial by fire that demands incredible heat and unbelievable precision. Okay, so the process starts by stretching out the pan to get its molecules all lined up. That's the foundation for all its future strength. Next up, it gets oxidized, which kind of locks that structure in place, so it doesn't just turn to goo in the furnace. And then comes the real magic: carbonization. It's cooked at over 1,000 degrees Celsius in a furnace with no oxygen, a process that basically incinerates everything that isn't carbon. What comes out the other side is a filament of almost pure carbon, forged to be unbelievably strong. And get this, if you need the absolute top-tier, highest performance stuff, the process gets even hotter. Some fibers go through an optional step called graphitization at a mind-boggling 2,500 degrees Celsius. To put that in perspective, that's nearly half the temperature of the surface of the sun, all just to get that perfect crystal structure. So now we have these incredible, super strong threads. But obviously, a single thread isn't a car or an airplane wing. The next big step is turning these raw fibers into the revolutionary products that are literally changing our world. Now, this is really important. You almost never use raw carbon fiber by itself. It's combined with a resin, like epoxy, to create what's called a composite, or CSRFP. Think of it like a partnership. The carbon fibers are the muscle, providing all that immense strength. The resin is the skeleton, holding everything together, giving the part its shape, and protecting those powerful fibers from damage. If you really want to grasp its impact, just look at a modern jetliner, like the Boeing 787. By weight, it is more than half composite materials. That is a massive, revolutionary shift away from aluminum. And it creates this amazing ripple effect. A lighter plane needs smaller engines and less fuel, which in turn makes it even lighter, allowing it to fly farther and more efficiently than ever before. So it's no surprise that in the high-stakes worlds of aerospace and automotive, carbon fiber is king. In a Formula One car, it forms a protective survival cell around the driver while shaving off precious milliseconds from lap times. In an electric vehicle, every single kilogram you save translates directly into more range. It really is the ultimate performance material.
And it's not all about speed and safety. In sports, it gives athletes a real competitive edge with lighter and stiffer equipment. Think pro cycling or tennis. And in renewable energy, it lets us build these enormous, more efficient wind turbine blades that can capture way more power from the wind.
The versatility is just astonishing. In medicine, it's strong enough for advanced prosthetics, but it's also transparent to X-rays, which makes it perfect for imaging tables. In factories, it lets robotic arms move with incredible speed and precision. They're even using it now to reinforce aging bridges and buildings to protect them from earthquakes. So it's pretty clear carbon fiber is a total game changer. But what's next? Well, the next chapter is all about tackling its biggest hurdles, making it cheaper, and really importantly, making it sustainable. And this is where we get to carbon fiber's central paradox. On one hand, using it makes planes and cars way more fuel efficient, which is a huge win for the environment. But on the other hand, the process of actually creating it is incredibly energy intensive. It's a really complex trade-off that engineers are now racing to solve. A huge piece of that puzzle is recycling. Now, the easiest way is to just shred it up, but that breaks all those precious fibers and you end up with a much weaker material. The real breakthroughs are happening with thermal and chemical processes. By using either intense heat or special solvents to carefully separate the resin, we can recover high-quality fibers that keep nearly all of their original strength. This is absolutely key to closing the loop and making carbon fiber truly sustainable. And the innovation here is just speeding up. I mean, imagine carbon fiber made from sustainable stuff like wood pulp, or smart composites that can actually sense and report their own damage. Scientists are even working on structural panels that can also act as batteries. The future isn't just about making carbon fiber cheaper and greener, but making it smarter and more capable than we ever thought possible. Which really leaves us with this final thought. Carbon fiber has already proven it can make our world lighter, faster, and stronger. The defining challenge for the next generation of engineers is to answer this question. Can we make our most powerful materials also our most sustainable ones? Because finding an answer to that is going to be a very big deal.